Hello, Dr. Vishal.
Hello, Reshma. Hi. A warm good evening to everyone joining today in today's session of Math Whiteboard. And welcome to GG Happy session. Reshma, what you?
Yeah, thank you so much, Dr. Vishal, and thank you for all of you joining our Saturday session of GEG Ahmedabad and Pune. So myself, Reshma Honap, I am a leader of GEG Pune, and we have Dr. Vishal, who is a leader of GEG Ahmedabad. So we bring in a lot of interesting sessions on Saturdays, basically to help our educators learn different digital tools that can help them in their classrooms. So today we have an amazing guest, a founder of a very, very interesting board. Hello, Don.
Hi, Don.
Hello.
So go ahead,
Glad to
Dr.
have
Vishal.
you.
Yeah, great to
Yeah,
have
Don,
you.
glad to have you today with us. Don is a co-founder, or is rather a founder for Math Whiteboard. And Math Whiteboard is a very apt tool for the educators as well as for the students to learn and to teach maths. So we're going to learn so much of tricks and tips today, how to use Math Whiteboard and how to use technology to make the remote teaching learning easy for the subject of math. So all the math lovers, all the math educators around the world, around the globe, today are going to join. And Don, for your information, we have over 300 people registered for this session, and all of them are educators. They are into their different respective zones, and we've got educators from different time zones today. So your session is highly valued, and we look forward to a very insightful and rewarding session from you.
Well, thank you very much, Dr. Vishal and Reshma. Thank you again for inviting me. I'm so excited and so excited that so many folks have decided to attend on their Saturday evening. Really appreciative of the attendance and folks' interests in Math Whiteboard. So thank you for inviting me.
So Don, when I came to, I'm a math educator myself, and it has been really difficult to show students and talk to students offline and online, basically to help them visualize what are the concepts behind all these things that we learn. Like my students ask me, are we ever going to use this quadratic equation in our life? Why do we need to do it? So we have these questions because it was always difficult to show them what in real life these quadratic equations are and what they do. So when we discovered the golden ratio and they could see those objects, but I think your tool is just going to amaze everybody how they can showcase students and help them in the classroom. So should we start the session?
That would be great. Thank you very much for the introduction. Okay. And I'm ready to go whenever you'd like to go. One of the things I'd like to ask you to do, either Reshma or Dr. Vishal, while I'm presenting, my face gets really close to the screen, and it's probably something that folks may not want to see. So if you wouldn't mind, while I'm working on the screen, if you wouldn't mind turning off my webcam, just so that folks don't have to worry about looking at my forehead really close up.
Absolutely, don't worry. And Don, we would love if you can tell a little bit about your work experience, your work profile to our educators, and then we can start the session right away.
Sure, happy to give a little background about myself as well as about our organization. So again, my name is Donald Carney. I happen to be the CEO and one of the co-founders of the company that makes Mathwhiteboard. Math Whiteboard has its origins in some PhD thesis work that was done at Brown University. Brown University is a university here in the United States. I happen to be based in Boston, Massachusetts, and Brown is in a state in Rhode Island, which is about an hour away. So it's pretty close, nearby Boston. But the research was done in a laboratory that focuses on user interface technology as well as educational technology. And I did my PhD at Brown, and my team, we all did our graduate work at Brown in computer science. So this originated as a computer science, the PhD thesis level project that was really geared toward an exploration of user interfaces in mathematics. And it was very well received, not only in the user interface community, the community of computer scientists who focus on user interface technology, but it was also, surprisingly, maybe not, in retrospect, not too surprisingly, but by the math educator community who looked at this system and said, holy cow, I've been waiting for something like this for my entire career. Can you please, make this available for the masses so that we can leverage this in the teaching and the learning of mathematics? So that's the origin of Mathwhiteboard. It stems from this core research. So we're a very research-based organization. We've been very fortunate to have received funding from some of our science organizations and the federal science organizations here in the United States, including the National Science Foundation, the NIH, and the U.S. Department of Education. So that's just a little bit of background about me and about our company that makes Mathwhiteboard.
Awesome. Thank you for sharing, Don. And let us begin. I think your fellow presenter is also here. Would you like us to?
Oh, James is here. Great.
James, MPLC, yeah.
James. Well, this is James is one of our summer interns. He's a high school student here in the United States. He's in the state Connecticut, and James will be exploring with us some of the research that we do this summer. He's already dug in on some of the work we do, and he's an expert in the area of social media. So he's helping us with social media marketing. But as I mentioned, we're also a very research-based organization, and James is not only interested in technology and marketing and social media, but he's also interested in the areas of research and how research is conducted.
We would be glad to have your view, James. Can you switch on your cam?
Okay. Oh, maybe James' camera is not working, but that's okay.
That is okay. Yeah. Let us begin it. Yeah.
So why don't we jump in? And I'll start. I'll give you the tour of Mathwhiteboard.
You need to share your screen.
Oh, I need to share my screen. Sorry about that. I always forget to do that. So why don't I share my screen, and I will click share screen. So we're going to share the whole screen here, and share screen.
Yeah.
And you should be able to see my screen now.
Yeah. Okay. Done.
Great. Awesome. So I'm gonna jump in, but before. Oh, I'm sorry. Yes.
While you are Don, you're just continuing, we'll be at the backstage. So in case you need us, just ask for us.
Okay, will do. Thank you.
Yeah.
So a couple of things before I jump in. As I mentioned, Mathwhiteboard has its origins in some research work that was done at a university, and it was an exploration of some very innovative technology that we have now put out into the hands of folks, and it's now available through Mathwhiteboard.com. And Mathwhiteboard.com is a free website. It's also what we call barrier-free. So what I mean by barrier-free is that Mathwhiteboard has no logins, no passwords, no accounts, no subscriptions. It's just a free website that you can go and you can use. And I should also mention that I happen to be running this on a Windows tablet, a Windows Surface device, but Mathwhiteboard works everywhere. I'm running this in the Chrome browser on my Windows machine. It will work on Chromebooks or iPads or MacBooks or any computer that runs a standard browser. And you'll also notice that I'm writing on the screen a lot with my stylus. And even though I'm using a touchscreen device, everything I'm doing with my stylus and writing on the screen can be done just as effectively with a keyboard and a mouse. And I'll show you that as we move along as well. So let me jump in and show you what Mathwhiteboard is all about. Oh, by the way, I have two Mathwhiteboards on the screen here, two browser windows open. That's not because I'm trying to double up on the promotion of the name Mathwhiteboard. It's because at some point I'll show you how Mathwhiteboard can be a shared, synchronous, collaborative space between users. So let me jump in and show you what Mathwhiteboard is all about. I'm going to start a Mathwhiteboard. So on the right-hand side, I'm just going to expand this browser window. And we'll start a Mathwhiteboard. So I just click on the new Mathwhiteboard button. I'll dismiss the couple of pop-ups that show up. And then let's take a look at what Mathwhiteboard is. Think of Mathwhiteboard as a smart piece of math paper. So for example, I can write some math. 1 + 2. That's pretty simple math, but you'll see it recognizes what I write, and I can get an answer. 1 + 2 is 3. I can change the math, and the answer will update dynamically. 2 + 2 is 4, or 3 + 2 is 5. I can change the 3 to an A, and then I can assign a value to A. And when I change the value assigned to A to a 2, you can see the answer A plus 2 updates dynamically. So when A is equal to 2, A plus 2 is equal to 4. I can change this 2 over here to a B, and then I can assign a value to B. And again, if I change the value assigned to B from a 3 to a 4, you can see the answer A plus B updates dynamically. I can write more math on the page. I can write A minus B, or A times B, or A over B. And all of these math expressions are recognized, and we also get answers. Now, underneath the hood, we have a very powerful computer algebra system that allows me to not only do very simple numeric arithmetic like you've seen me do so far, but also some algebraic arithmetic that you've seen. We also can do some more advanced math topics. So here's a definite integral for all of those calculus nerds out there, of which I happen to be one, so no offense. So now when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. I can change B to a 7, and again, all of the answers on the page update dynamically. I can even assign to A an expression like x plus 1, and now x plus 1 substitutes for A across the page. So as math educators, we know that learning mathematics is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, like plus, minus, divide, and so forth. In algebra topics, we also look to see connections with graphs and tables and other types of mathematical representations. So let's take a look at a math expression that we're all familiar with. Y equals mx plus b. This is the slope-intercept form of a line equation. M is the slope, b is the y-intercept. I've written it on the page, and it recognized what I wrote. With a simple gesture, a swoop of my pen, I can create a graph. I'll do that again, just a quick swoop. And I've got a graph on the page. I can pinch and zoom with my fingers the graph. And you'll notice if you're a math educator that we have selected default values for M and B because there's a plot in the graph, and the plot has a slope of 1 and a y-intercept of 1. But I can change that. I can make M equal to a different value. I can say M equals 2, and the graph will update dynamically. Or I can make it equal to 3. And again, the graph will update dynamically. I can be more interactive by creating a slider for M. And now I can show very visually what M, or slope, really represents. What slope? That slope. When slope is negative, it looks like this. When slope is positive, it looks like that. B is the y-intercept. I'm going to create a slider for B. The way you create a slider in Mathwhiteboard is when you have an assignment, like a variable equals a number, in this case, B equals 1, you draw a straight line down from the equal sign, and you'll see a slider displayed. So I'm going to draw a straight line down, just like that, and now we've got a slider for B. And now, when I vary the value of B, we can see the graph updating. But you know what? I'm not exactly sure what B is really doing to the graph over there. It's supposed to be the y-intercept, but I'm not sure what's happening. Let's take a look at this point so we can further understand what the y-intercept really represents. That's 0, comma b, and I can just plot that with a quick swoop into the graph area. Now that point, that coordinate 0, comma b is plotted with the blue dot there. And when I change the value of b, now we can see what b, the y-intercept, really represents. It's that point where the red line passes through the y-axis. That's the y-intercept. So there's something I say often that I think it's really important. Learning mathematics is about seeing connections between things. Here, we're looking at the relationship between an algebraic expression and a graph. Often in the math classroom, the math teacher or the math student uses a primary workspace for doing math. We all use a primary, the paper and pencil workspace. That's the primary workspace. And we all use paper and pencil. I even use, even though I have fluid Mathwhiteboard, I even use paper and pencil sometimes to do math problems. But that's our primary workspace. And we use all of these complementary or secondary workspaces like graphing calculators and computers to look at graphs and tables and diagrams and solutions. But all of a sudden we've got these multiple workspaces and they're all disconnected from each other. How do you see the relationship between what you've written on paper and what you see on the screen of a calculator? You've written on paper with a pencil and you've entered with a keyboard notation into the calculator. The representations, the mathematical representations end up being, in different workspaces and far from each other, not just physically far from each other, but cognitively as well. So what we try to do with Mathwhiteboard is bring together into one workspace all of the mathematical representations and allow the user to move very fluidly between those mathematical representations while hiding behind the scenes all of the technical stuff. Let me show you another example that really demonstrates this in a very powerful way. And the thing I'm going to demonstrate here is this concept of being able to see connections between representations in one workspace. So we'll take a look at a related rates problem. So we'll take a look at a couple of cars. Yeah, those are cars. I'm not an artist. And we'll say this is car A. We'll label the cars, car A and car B, and we'll give length to the road. And we'll say that car A has a constant velocity of 80 kilometers per hour or 80 miles per hour, or said in mathematics terms, the location of car A along the x-axis is defined by 80 units of distance per unit time. Car B is a police car that has to accelerate to catch car A. We use a quadratic to describe constant acceleration. So in Mathwhiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. So under the More menu, I can turn on math sketching. And now you'll notice that the mathematical expressions became highlighted in different colors associated with their labels. And we saw a slider pop up on the page here. Now on the right-hand side of the slider, there's a play button. When I press the play button, we can see the cars moving across the screen in an animated simulation as described by the math I just wrote on the page. Pretty cool for us, and we're adults. Imagine what happens when you show this to kids in the classroom. Their heads explode. They're engaged. They're asking really great math questions like, can you make the car go faster? Or can you make the car bump up and down? Now, of course, what's happening here from a high-level pedagogical perspective is that we're making a connection between this very abstract algebraic notation we see on the left-hand side here and a very concrete example we see on the right-hand side. Everyone knows about driving cars down the street, especially kids at the middle school and high school level who are eager perhaps to get their hands behind the wheel of a car. So we're all familiar with that. And sometimes that's when the learning happens in the math classroom, when we can make the application and see the associations and the connections between that abstract stuff we're learning in the classroom and the real world. How do we apply the mathematics? Because oftentimes students will walk into the math classroom and say, why do I need to learn this? Who cares about algebra? When will I ever use this again in my life? When you realize that algebra can be applied pretty much in everything you do, even in things like driving the car down the street, you then realize and have an appreciation for why learning mathematics is important. Now, of course, that's from a high-level pedagogical perspective. From a very practical perspective, this is a related rates problem. And related rates problems show up on standardized exams all the time. And they usually come along with a couple of questions, like, at what point in time does something happen? Or at what point in distance does something happen? Here, the question is, when does car B overtake car A? So if I run the simulation, we can see that car B overtakes car A just about there. Well, that's a math observation, not a math answer. We want to get a math answer. And how do we do that? Well, there's a couple of different ways to do that. As I mentioned earlier, we have a very powerful computer algebra system underneath the hood. And if you're familiar with these types of systems of equations, you know that you can set them equal to each other and solve. So in this case, I could set a sub x equal to b sub x, and I can then solve for t, and I can get an answer. But that's only if you know that you can set the equations equal to each other and solve. Oftentimes, what we'll want to do is we'll want to explore. And I like to think of this as the scientific method, where we're going to come up with a hypothesis, test the hypothesis, and then prove it. And the way we might do that with this system is that we might graph the functions. Oh, and by the way, I did one graphing gesture through both expressions, and I can get a graph. And then I can pinch and zoom the graph with my fingers. And we can see that that there are points of intersection. There's one point of intersection at the origin. There's one out here in the distance. And that's in the quadrant. So the point of intersection at the origin, that's where the cars start. And the one out in the quadrant where the quadratic overtakes the linear, that's where we hypothesize that car B, the accelerating car, will overtake car A, the car with the constant velocity. And that's because the quadratic or the parabola overtakes the linear at that point. And we can see from the graph that happens at about 8 units of time and about 650 units of distance. So that's our hypothesis. When time equals 8, the car should be at about 650 units of distance. So let's test the hypothesis by running the simulation again. So I'm going to go to the More menu, turn on my math sketching to get the slider to come up again. So I'll run the simulation for 8 seconds, and all I'll do is I'm just going to grab the T and drag it over to 8, and we can see the cars are at about the same location. So we know that we're approximately correct. We don't know that we're exactly correct because we're just eyeballing the graph and we're eyeballing the simulation, but we know we're on the right track. Let's prove it. The way we prove things in algebra is through substitution. So I will substitute in the value of our hypothesis when time equals 8 to see if the location of car A along the x-axis is what we think it might be from our simulation and from the graph, about 650 units of distance. Let's see. 640, pretty close. If b sub x is also 640, then we know we've proven the hypothesis. Cool. So I love this example because it demonstrates the power of having multiple representations in one workspace. You know, you've got the algebraic representation, you have a simulation, you have a solution, you've got a graph, you could look at even at a table of values. And everything is connected. So when the student says, hey, make the car go faster, well, we can make the 80 miles an hour, 90 miles an hour, and look, all of a sudden, you know, the graph changed. The point of intersection moved, and the solutions changed as well. So let me pause for a moment and see if there are any questions or if there are any comments at all. There's still a lot more I'd like to share, but let me see if there are any comments we have. Were there any comments in the any questions that came up? Oh, Reshma, I think you are muted.
Muted, yeah.
Oh, so sorry. Don, there are amazing comments in the chat. You should go back and see it. But everybody is really odd with what you are showing them and what your math whiteboard is doing with all these equations and parabolas and the rate problems that are always the toughest for the students in the school because they can never relate it to actual driving a car with the algebraic equation that is being shown on the screen. So that is going amazing. A couple of questions is that I know you mentioned it in the beginning that this can be used with any of the operating system, right?
That's correct. So I'm running this in a browser. I'm running this in the Chrome browser. So even though I'm running this on Windows, on a Surface tablet, this will run on a Chromebook. It will run on a MacBook or an iPad or even in Linux, I think it would work, or a Windows machine as well.
Excellent. And there is one question that popped up a couple of minutes back is that can it also be helpful for chapters like physics, like motion in certain phases, friction or other things? Would these equations can be shown?
That's great. Great question. So although it's sort of the primary focus for us is mathematics, there are definitely applications in other sciences, like, for example, physics. You can see, obviously, this is a physics example, functions of time. Sometimes the way I like to describe it is that if you can write the algebraic expression for what you need to show, then you can also demonstrate the physics that's happening. Now, things like collisions and so forth, our simulation engine doesn't handle that at the moment. But the simulation engine is pretty cool. You can also apply a y component as well to your functions here as well. So let me show you an example. So if I wanted to see the y component of a, I could do a sub y equals, and what we'll do is we'll do a sine function. So we'll make the card bump up and down. So so if I specify that for the y component, and then I bring up my math sketching slider again, and now I play that, we can see the car bumping up and down.
Oh my God, okay, yeah, awesome. Yeah, can you just demonstrate it one more time? Where did you get the slider from?
Oh, okay, sure. When you're in Mathwhiteboard and you have not turned on math sketching yet, you have a math page that might look like this, where there's some drawings on the page and there's some math on the page. And by the way, I drew the cars with the draw pen up here, and I drew the road with the draw pen, and you write the math expressions here with the math pen. So you can see up here, there's a button that says math writing, and there's a button that says draw. And now under the More menu, we can turn on math sketching, and that brings up not only the slider, but it also associates handwritten mathematics expressions with labeled objects that are drawn on the page. So now when I have the slider, I can press the play button on the right-hand side of the slider, and now the car A will bump up and down.
Excellent, amazing. And then if I understand it correctly, the slider goes with the recent equation that we have written, right?
That's correct. So when I move T on the slider back and forth, you can see the cars moving on the page.
Mm-hmm. And then can I use this slider to connect it with the earlier equation like A of x or B of x, or there is a new slider that should come up for that particular part?
Oh, well, the slider here is for T. So what we're varying here is T, the value of T. So anything that has the variable T in it, so for example, these two functions here, both have a T in them. So what we're doing is we're varying that value. So those functions are updating dynamically as we're changing this. And we're also, not only is the graph changing, but you can see that the values of the solutions are changing.
Oh, yes. I see that right now. Yeah. So everywhere where is T on the variable is same, it changes the value of it.
Yeah, and that's keeping in the spirit. That's keeping in the spirit of Mathwhiteboard, where we want to have, everything's in the same workspace, but everything's connected, so we can see the relationships and the connections between all these mathematical representations.
Beautiful. One last question, and I will let you continue with more. Our audience would really love to see how it can be implemented with the younger kids, like primary or up to 5th or 6th graders, like what other tools are available. And another thing is, do we have a geometry tool or probably a ruler or a compass that can be used?
Yeah, great question. So I'll answer the second question first, and then I'll answer the first question. So with regard to geometry, we don't have tools yet for geometry. So we do the algebraic side of geometry. We do pretty well with trig functions and so forth. But on the the construction side and things with compasses and so forth, we don't have those yet. But stay tuned. We're always evolving the system in terms of breadth and in depth. So stay tuned for that. Now, with regard to the first question, things to do and apply at the lower grade levels, let me show you an example of a pretty interesting bit of functionality. So I'm just going to create a new Mathwhiteboard for this demonstration here. By the way, I'm just clicking this new Mathwhiteboard button up at the top of the page. That just clears my page and it creates a new Mathwhiteboard. So we have this really interesting bit of functionality built into Mathwhiteboard that I don't think you'll see anywhere else. I think it's pretty unique to Mathwhiteboard. We call it algebraic equivalence testing, and I can turn it on under the More menu by just by selecting Highlight Equivalence. And now anything I write on the page will be highlighted the same color as anything else on the page that is equivalent. So, for example, the number 3 and the number 2 are not equivalent to each other. So they're highlighted different colors. And the number 4 is not equivalent to 3 or 2. So again, it's highlighted a different color. But the number 6 over 3 is equivalent to 2. And you can see now its highlighting has changed to the same color as 2 because now those are equivalent numbers. 4 over 2 is also equivalent to 2. So again, that will be highlighted the same color. Now, you can imagine using this highlighting of numbers and fractions and decimals and so forth at the lower grade levels where we might be doing things like matching numbers and so forth. So if I turn off the highlight equivalence and I put some other numbers on the page, maybe 5, maybe 10 over 2, and maybe, nope, I want to move that 2 up a little higher there, and maybe we do 20 over 4. So now we've got some numbers on the page, and you can imagine the game that's about to happen. We have to match things, right? So, well, 20, what's equivalent? Well, 20 over 4, and well, these both have a 4 in them, so they've got to be equivalent, right? And 10 over 2, well, that's, I don't know if that's equivalent, but maybe 5 and 10 over 2, those are equivalent. And 2, that looks like the 2 and the 4 over 2, those are equivalent. And man, I don't know what 6 over 3, that's an odd looking fraction. So now when I go back and I turn on highlight equivalence, we can see how well we did with the matching. Oh, look at that. Well, the 20/4, that should have been over here. And the 6/3, that should have been over here. So you can imagine using this at the lower grade levels where we're looking at equivalent fractions and equivalent decimals. We can also apply this at the higher grade levels where we are looking at things like algebraic equivalences. So for example, A plus B and B plus A. These are, this is an identity. We can see that those are equivalent, but A minus B and B minus A are not equivalent. So they're highlighted different colors, and then A times B and B times A are equivalent. So they're color coded the same. And then A over B and B over A are not equivalent. So they're highlighted different colors. Now, that's at the, we've seen so far some numeric equivalences and some equivalences at the algebraic, simple algebraic identity level. We can also apply this either in geometry or in algebra 2 or pre-calculus where we're looking at trigonometric identities. So for example, tangent of theta is not equivalent to sine of theta, right? So they're color-coded different colors. But sine of theta over cosine of theta is equivalent to tangent of theta, so now it is color-coded the same. So pretty cool that we can use these for identities. Now, perhaps the most powerful way in which to use this highlighting of equivalent expressions is really in step-by-step problems. So let's take a look at a step-by-step problem. It's just a simple one here. Let's say we have 2x plus 3y equals 4, right? And let's say we want to solve for x here. So the first step we might take is we might move the 3y over to the other side. Let's do that. So the first step here would be 2x equals 4, and then we're moving 3y over, right? So it's plus 3y, right? Hey, wait a second. It's not color-coded the same as the original statement. I must have done something wrong because we know that every step in a step-by-step problem should be algebraically equivalent to any other step. But these two expressions are not color-coded the same, so I must have done something wrong. Gee, what did I do? Well, we all know that I forgot to change the sign when I moved the plus 3y over the equal sign. So if I change that plus to a minus, now all of a sudden it's color-coded the same. So what we're doing here is we're giving immediate feedback to the user, to the student, as they're making mistakes in their step-by-step problems, or as they're getting the steps correct. And getting immediate feedback on step-by-step problems can be really powerful because you invest a lot of time in these step-by-step problems, and then you may only realize at the end that you've made a mistake. So we can continue on here and say x equals 4 minus 3y over 2, and we can see that that's the same color as well. So we know we've come up to the solution correctly. And as I was just saying, it can be very frustrating, especially for students who are struggling, and especially as we move along in mathematics and these step-by-step problems become longer and longer. They can have 10 or more steps, and you can be investing many minutes. Some of these step-by-step problems can be, you can be investing 10 or more minutes trying to solve these things. And especially for students who are struggling, when you get to the end and you realize, I got the wrong answer, or I must have made a mistake somewhere. And you're looking back and you're saying, there's so much math on the page. Where did I make a mistake? Should I just start over again, or should I just forget it and move on? So again, what we're doing is we're giving that immediate feedback to the student that a mistake has been made, or that they've done the step correctly, and then they can have confidence to continue on. Now, this can also be applied. The question was about the question earlier was, how do we apply this at the lower grade levels? Of course, at the lower grade levels, we're doing order of operations types of things. So for example, let's take a look at this. 2 minus 3 times 2 minus 3, right? If we were to solve this, we might first multiply the 3 across the parentheses, right? So let's do that. So the first step here might be 2 minus 3 times 2, that's 6. And then minus 3 times minus 3, that's minus 9, right? Oh, wait a second. It's not color coded. It's not equivalent. What did I do wrong? Oh, minus 3 times minus 3. That should be a plus 9. That's right. Minus times a minus is a plus. Okay, cool. I did that step correctly. Now the next step is 2 minus, and then 6 plus 9. That's 15, right? 15, right? Okay. Oh, wait a second. It's not colored. What did I do wrong? Oh, it's minus 6 plus 9. Oh, that's right. So that should be minus 6 plus 9. That's plus 3. And then, of course, we know what plus 2 plus 3 is. That's 5. So now, there's always more than one way to solve any math problem. That's one way to solve it, like this. Another way to solve it is like this. 2 minus 3 times minus 1, right? And that step, of course, is correct. And then the next step, of course, here is 2 minus 3 times minus 1. That's going to be minus 3. And then, oh, wait a second. It's not. Oh, what did I do wrong? Oh, minus times a minus. That's a plus. I always do that. Oh, man. So that's 2 plus 3. And that should be 5. Okay. So pretty cool, because this color coding, can be applied at all sorts of grade levels. And we start doing step-by-step problems pretty early on, even in order operations types of things in our math learning. And then this can be applied all the way through high school and then into some college as well. So I think a pretty cool bit of functionality. I'd love to hear any feedback that folks have on the color coding, if there is any.
Yes, Don. Teachers are really amazed with the color coding, because just like you mentioned, it is a great way for immediate feedback for even students who are doing the work asynchronously as well as synchronously with the teacher. So self-learning is excellent, because they don't have to wait till the end to get it incorrect and then go back step by step to see where they went wrong. So it's a great, and that is the feedback exactly about what teachers are saying.
Great. I saw that there was a question about sharing the boards, and I think that's good leading question onto the next topic I wanted to talk about as well.
Yeah, just a quick question. I like that question also, and the question is, if it is a very long problem that you're solving, does the board just keeps increasing and you scroll down, or it's just limited to the screen?
That is a great question. So you'll notice that there's a scroll bar on the right-hand side of the page, and it seems to be limited, right? But it expands when I start writing near the bottom of the page. So if I were to write something near the bottom of the page, you'll see that now some extra space has been added. And if I add some more at the bottom of the page here, yet some more space has been added. So you can continue to add more and more space at the bottom of the page by just writing ink, whether it's math or drawing ink, near the bottom of the page, and the page will continue to expand. Great question.
Awesome.
And
awesome.
That also works on the right-hand side of the page as well.
Mm-hmm. Excellent. Another last question before I interrupt you, Don, because educators really are amazed with what it is, and all those thoughts are coming into their minds and mine too. It is that, can you prepare the boards early before the class? Like, is there a way to have a background prepared or something that is already prepared and then we use it in the class, or is it like we start fresh every time?
That is a great question, and I have a couple of answers to the question. So it's a multiple choice answer where the answer is going to be E, all of the above. So the first answer is that the spirit behind Mathwhiteboard, and because we have no account, we wanted to create a system with no accounts or logins. So one of the challenges you face with creating a system where there's no barriers, there's no accounts or logins, is that saving things to an account, that doesn't make sense when you don't have logins or accounts, so you don't save these things. The analogy I use for Mathwhiteboard is that it's kind of like your chalkboard in your classroom. You come in the morning, it's a clean slate, and you start working on it. And then for the second period, where you're teaching a new group of students, you clean it off and you start with a clean slate. That's the analogy I use with Mathwhiteboard. Now, we've been asked over the past several months since we've launched this, especially recently, exactly that question. How can I save these things? So there's a couple of different ways to do that. I'm going to show you first the way in which to cheat and do it. Maybe it's not cheating, but it's kind of one way to do it, not the most efficient way. And then I'll tell you the more efficient way. So every Mathwhiteboard, you notice, has a unique URL at the top of the page. So when on the left-hand side, if I create another Mathwhiteboard on the left-hand side, you'll see that the URL on the left-hand side is different. So the URL on the right and the URL on the left are two different URLs. You see up here, this URL and then this URL are different from each other. these are two different math whiteboards. Now, if on the first math whiteboard, I have something written, maybe y equals x with a graph, and maybe this is my starting point. Oh, I want that to be x. Maybe this is my starting point for an activity. Simple. I can take a page from math whiteboard and hit Control C. I can just, oh, by the way, on the slide, I did this pretty quickly. On the left-hand side of every math whiteboard, there's a slider that pops out, and it's a slide sorter, so I can have multiple pages to my math whiteboard. But each of these pages is copyable. I can copy this. So I can click on the page, hit Control C, and then I can copy that not only within the same whiteboard, so I can copy that here within the whiteboard. Now I have two pages that are identical. I can also copy it into another math whiteboard. You can see that on the left-hand side there. So one of these could be your master copy, and another could be your copy that you're using in the classroom. Maybe the copy on the right-hand side is what we're using in class, and the copy on the left-hand side is the master copy that for each class I'm copying from that. Now, that's not entirely efficient or perfectly efficient because you know, there's a lot of copying and you have to keep track of these URLs and stuff like that. Another solution, and this is, so I have to give a little bit of a history about our company here. Our company's been around for a little bit more than 10 years, and we've kind of taken a little bit of an opposite approach of some other companies out there that will launch a product and then release it for free until they get a lot of users, and then start charging for it or start charging for pieces of it. We've been around for about 10 years, and our opposite approach was that, you know, we have been selling another product that's called Fluid Math. And Fluid Math looks a lot like Math Whiteboard, but it is a subscription-based system where you have accounts and you have logins and subscriptions and so forth. And in the Fluid Math system, you can save these documents. So because we've been asked this question so many times, we've just recently implemented an integration between Fluid Math and Math Whiteboard, where now you can save your documents in Fluid Math, and then there is a share button in Fluid Math where you can click the share button, and that will now open it in Math Whiteboard. So effectively what you can do is you can save your documents in Fluid Math, you can build them and save them, and then when you want to use them, you just click on the button that says share to Math Whiteboard, and it will open it up in Math Whiteboard, and then you can share it with your students who don't have accounts. And by the way, the Fluid Math system is a pretty reasonably priced system. It's very cheap. I think it's $15 or $20 US for a year subscription. So it's pretty reasonable. A lot of teachers have been purchasing their a Fluid Math account for just this purpose. So the answer to the question is E, all of the above. What I just said there for the past couple of minutes. But a great question. Thank you for that. So continuing on here with some more of the functionality within Math Whiteboard, I think someone in the chat had asked the question, can these Math Whiteboards be shared? And as I just mentioned, each Math Whiteboard, when you click on New Math Whiteboard here, it opens up a new URL. So you can see each Math Whiteboard has a unique URL. And when I click on the copy link button here, that will copy the URL to my clipboard. And then I can paste that into like a Google Doc or Google Classroom to share with my students. But I can also just paste that into a browser window, like on the left-hand side. I can email it to a student. The student can click on it. And when the student opens it up, you're now sharing the same collaborative space. So think of these two browser windows that I have on the screen here as two different users on two different computers, maybe a teacher on the right-hand side and a student on the left-hand side. So when the teacher on the right-hand side writes something, so for example, if the teacher writes y equals x, the student on the left can see it in real time. But it's not just that they can see it, it's live. They're sharing the same piece of Math Whiteboard. So I wrote that originally on the right-hand side. Now, as a student, maybe I'm going to edit it on the left-hand side. So now I'm editing it on the left-hand side. And of course, all of those tools that we've seen available, all the math representations and the math tools are available on either side. So when the student makes a change on one side, so maybe, for example, we put a slider on here and the student changes the slider a little bit, the teacher can see in real time the changes that the student is making, and likewise, the student can see what the teacher is doing. Now, a pretty interesting bit of functionality here that we have implemented is being used in a way that we did not expect. We've learned that math teachers are very creative people, and they've been using this this functionality, this slide sorter on the left-hand side in a very unique way. What they're doing is they're assigning groups of students to slides. So for example, what they'll do is they'll make a copy of the slide, so hit Control-C and hit Control-V a couple of times, and then they'll assign to each of the slides a different group of students. So maybe this is slide 2 is group 2, and then on slide 3, we have group 3. And on slide 4, maybe we have group 4. Okay. So let's say, for example, the student on the left-hand side, maybe this is James and Caroline working together on the left-hand side slide here. And James and Caroline changed their pen color to green. So what they're going to do is they're going to start editing this document. And, Caroline is going to write some math on the page. So Caroline writes y equals x on the page, right? Now, what's cool here is that the teacher can see in real time that that slide has been updated. Now, James is being a little silly, so James decides that he wants to write some smiley faces on the page over here. So he's going to write, a smiley face, and then, of course, the teacher can see in real time over here on the right-hand side that that page has been updated dynamically as the teacher's doing it. So now the teacher, if the teacher wants to, the teacher can jump onto that slide and turn on her red markup pen and say, hey, what's going on over here? So it's kind of an interesting way for teachers to have students working in small groups while also being able to monitor what they're doing in real time. So I'm going to continue on. There's a few more things I'd like to share. So let me show you a few other really interesting things. So I'm going to, on the right-hand side, I'm going to create a math whiteboard. I'm going to dismiss the screen on the left-hand side. Now, this next bit of functionality is a math teacher favorite. So math teachers are well known to have folders full of PDF files. I have a folder here with, it's a homework assignment folder with 9 or 10 PDF files in it. Some math teachers will have hundreds of PDF files in lots of different, very well organized folders. So I'm going to open up one of these worksheets, one of these PDF worksheets, solving systems of equations. So you can see this is just a PDF file. It looks like any other math worksheet. Looks great. It's just a PDF file. But I can take any PDF file and I can drag and drop it right into Mathwhiteboard. And then that PDF file becomes the background for my Mathwhiteboard, upon which I can do all of my cool Mathwhiteboard stuff, like write math on the page, and I can put graphs on the page, and I can get solutions. I can also just mark up the page. So let's say we're going to mark up this problem here, and we're going to work through the problem, and then down here at the bottom we'll put an answer, and then maybe I change my pen color, and we're going to work through this problem over here, and then we got an answer over here as well. So what was a static PDF file that we printed out on paper and handed out to our kids now becomes a live, dynamic, interactive mathematics web page that can be shared collaboratively between users. And by the way, this was a multi-page PDF file. It had 2 pages. So every page gets imported as a separate page in Mathwhiteboard. And, if you don't want to do the math part, you don't have to do the math. You could just use this as a markup tool for marking up PDF files. In fact, this didn't even have to be a math worksheet. This could be a history worksheet where we're just marking up the page with our draw pen. So kind of a cool bit of functionality and definitely a teacher favorite, especially during the pandemic because of all the online learning and the opportunity for math teachers to leverage those resources in PDF files that they've gathered over many years. So one more bit of functionality I'd like to share with you here. I'm going to create a new Mathwhiteboard. And I mentioned early on that everything I was doing on the screen, everything I would do on the screen here with my stylus and my finger with the touch screen could be done just as effectively with a keyboard and a mouse. So even though I've been writing on the screen here, I can do everything I did with a keyboard and a mouse. So let me show you how. You'll notice that up at the top of the page, there's a draw pen and there's a math writing pen. The draw pen is used to draw things like smiley faces. The math writing pen is used to write math. And you'll notice with the math writing pen, every time you write something, it gets recognized. You would not use the math writing pen to draw a smiley face because that is not a math symbol. Even though maybe it should be a math symbol, it's not a math symbol. And the system tries, Mathwhiteboard tries to recognize it as a 0. But in the middle here, we have math typing mode. So when I turn on math typing mode, I can type math on the page. And I'm just going to make sure my highlight equivalence is off because I don't want that turned on. So I can type math. I'm going to type y equals ax squared plus bx plus c, right? So I just typed that with my physical laptop keyboard. But you know what? Not everyone knows how to type math with their physical laptop keyboard. Like, how do you type x squared? I happen to know what the control sequence is, or the keyboard shortcut to enter the superscript for the squared there, but not everyone knows how to do that. There's not an x squared key on my laptop keyboard. There is on my calculator, but I'm not on my calculator at the moment. So what we have in Mathwhiteboard is we have a calculator keyboard down at the bottom of the page, and you can see that I can just pick and peck at that with my mouse. So I'm going to pick y equals x squared. Okay, so I just typed that on the page using the virtual keyboard that's on the bottom of the page. And just as a hint for folks who might be using a keyboard, you've seen me use the graphing gesture, that big swooping gesture to graph things. You don't use that when you type math on the page. Instead, what you'll do is you just go to the insert menu, select graph. That will put an empty graph on the page. And now we can drag and drop these math expressions right into the graph area. And you can see those graphs plotted. And A, B, and C are clickable in this math expression. So when I click on A, I get a slider for A. When I click on B, I get a slider. When I click on C, I get a slider. And these, you know what the sliders do. When I manipulate the sliders, the graph updates dynamically. Now, typing math on the page can also be beneficial because it's more well formatted. My big, ugly handwriting, maybe it doesn't look so good, and it certainly takes up a lot of space on the page. So maybe we don't want that on the page. Now, underneath my handwriting here, that's actually a button right there. When I click the button, my handwriting will go away, and I'll be left with just the typeset math. So I'm going to do that right now. I'm going to click the button right there. My handwriting goes away, and I'm left with just the typeset math on the page. Now, I can take that math expression, this y equals mx plus b, and I can drag and drop it right into the graph area, and it's plotted. And if I want, I can put another graph on the page. So let's say, for example, in addition to using the insert menu to select graph, I could also just draw a big plus on the page, and that will put an empty coordinate plane on the page. I can drag and drop that into the graph area. And now we've got the y equals mx plus b plotted in two different graph areas, but you'll notice there's one B slider on the page. When I change B, everything associated with B on the page updates dynamically. So the parabola in the first graph and the line, and then the line in the second graph. Now let's remove these for a moment. Since we were just mentioning that this is a more well-formatted page that we might want to share with our students, we might also want to put some instructions on the page. So up here we have a text box button. When I click on text box, I can now type instructions into the page. So I'll type some instructions. Play with the sliders. I'm going to retype that. Okay. That's some simple instructions. Of course, if this were a real assignment or an activity, you'd make them more extensive, but you get the gist. These text boxes are actually really cool. I can do some interesting things. One of those really interesting things is that I can embed a YouTube video. So I have queued up here in this browser tab window I think this is a SolCon video where SolCon is talking about the quadratic equation, which might be appropriate for this lesson. As you know, with all YouTube videos, you can always click, there's a share button. I can click on that. I can click on embed, and then I can copy the embed code from YouTube. And then when I go back to my Mathwhiteboard, if I go to that second text box and click edit, I can click insert, media, and then I can just paste the embed code for that YouTube video right there. And now all of a sudden, we have a SolCon video, a YouTube video built right into our Math Whiteboard. And by the way, it's embedded, which means that it plays live right there in the page. It's not like you click on the link and it opens up in a different browser tab or browser window. Instead, it's live right there on the page. And that's keeping in the spirit of Math Whiteboard, where we want to stay in the same workspace the whole time. You want to have all of your mathematical representations in the same workspace, because when you start moving between browser tabs and browser windows and devices, all of a sudden you start to lose the connections between all of the representations. So that was the grand tour of Math Whiteboard. I'd love to hear if there is any feedback or any questions that you might have.
Oh, what a wonderful session, Don. And it's really overwhelming to learn about all the tools, all the facilities that the Math Whiteboard is having. Teachers are having many questions. They got many feedback, but I think there's one particular answer to this is that, why don't you try it yourself? So, and you got any doubts when you try, you get on Twitter, which is @Math Whiteboard, and you get the answers there. You can ask the questions on Twitter, you can get the answers there. So really an interesting session today, Don, and plenty more things to be learned from Math Whiteboard. And yes, one particular feedback that I would like to share here is that for those students who would find math little boring or uninteresting, especially when it's difficult to make them understand the algebras or geometries, I think Math Whiteboard is the best solution. So again, this is really a wonderful tool you have developed. So kudos to you and your team for developing this it's a boon for the teacher as well as the students. So thank you for this wonderful discovery and research.
Oh, thank you, Dr. Vishal. Much appreciated.
Yeah, and I think that will surely change the ways even students look at mathematics, because math is one of the absolutely not required subject as per the students, except a few who really love it and pursue it further. And for all the students, I think to see things happening real life and what it is, and a teacher to be able to relate the real life scenarios with why are we writing all these equations, I think that's really wonderful tool that can be used in the classroom, as well as even the students can try it at home, all the options. So I actually cannot wait to explore it more, going more deep into each part of it. So all the educators, feel free to watch the session again. It will be on GEG Ahmedabad and GEG Pune YouTube channels, and you can rewatch it, try it yourself. Any questions? Don is amazing. He's always responsive on Twitter, and he's giving this tool and website for free for educators. So that is amazing thing to share. So that just shows his passion in this subject. So thank you so much, John.
Oh, Reshma, thank you so much. Yes.
Yeah, really humbled by your approach by providing this as free tool for teachers and students. I mean, this is really amazing. And I'm sure the teachers today who have attended the session would be making use of Math Whiteboard in their regular math sessions. So this is really amazing. Thanks again to you and your team for making this discovery and the research. Oh, it's really hard work, and you made it really, you make it appear it's really easy to work with Math Whiteboard. Really fantastic.
Yes, and we look forward to connecting with you, Don, again with any new updates that you come. We would love to hear that, see that, and use it in our classrooms.
Great. Well, thanks again, Reshma and Dr. Vishal. I really appreciate you giving me this opportunity to chat with your community and to show off what we do with Math Whiteboard. It's always fun showing it off, and we're very, very encouraged by the positive feedback that we get. So please, if you happen to find things that you love about it, please do share that. And I always ask folks, we're a small educational technology company here in the United States, so we don't really have a massive marketing budget. We kind of depend on educators spreading the word about Math Whiteboard through word of mouth. So for all the folks out there, if you happen to be a part of any professional community, or if at your school or your district you want to share this, please feel free to. We'd be very appreciative if you do.
Don, a few requests that came up, maybe not now, but going in the future. Teachers really want to see something like objects or tools that can be used with primary students. So something like fractions, or like having a circle that can be broken down into parts and showing them parts and whole, or something like that.
Yep, absolutely. That's on our list of things to do. So great suggestion. Thank you.
Okay, thank you so much, and thank you all for attending the session. And feel free to let us know how you like it. Dr. Waria has already shared the feedback form with you all, and we will share it with Don with any more things that you would like to have added to my math whiteboard that can be helpful in your schools.
Yeah. So that's all for today's session. Thanks, Don, for sharing your time and expertise with us. Thank you, one and all, for joining us with us today, spending your valuable weekend with us. And yes, please spread the word about Math Whiteboard, and more importantly, please start making use of it. So your suggestions are very much important to us, and especially to Don, because they are still researching on the tool. So thank you once again.
Okay.
Right, Rashmi, let's conclude the session here.
Right, okay, then. Thank you, Don. See you all. Bye.
Thanks, everyone. Have a good day.